Today, we will have three interesting projects that will be presented from Horizon 2020. Some are finished, some not. They will present today three projects. The first one is virtual, second one Hydrin, and third one Panacea. You have to know that in total, in Horizon 2020, we have financed more than 20 projects on road safety for a total funding of 100 million euro. Having said that, I will not go too long, and I will introduce directly the first project presentation, which is virtual, open access virtual testing protocols for enhanced road user safety. This project is resulting from the Horizon 20 call topic from 2007 on protection of road users in all crashes. You have to note that in addition to this project, two other projects were funded by Pioneers and Oscar. And today, we are pleased to welcome Professor Astrid Linder, who is the coordinator of the virtual project. She's also professor of traffic safety at VTI in Sweden, responsible for the development of research in the research area of traffic safety and biodynamics. But she's also associate professor in the Chalmers University. So, Astrid, the floor is yours.
Thank you very much, and thank you for the introduction.
Just a question, can you see, or should we move a little bit? It's okay?
Yeah, okay. And good morning, everybody. So I will tell you about the virtual project, which we have just recently ended. And it has been a 4.5-year journey. Yesterday we heard that we shouldn't have so small project, and this was maybe on the border of what was a big or a small project. But for us in this area, or for me, it has been quite big. and you will see that we have also achieved quite a lot. So we have been running for, as I said, 4.5 years. And our aim was to reduce the loss of life and health in the road, in road crashes. So it's a focus on crashes, prevent them, but also to reduce the risk of being injured and killed when there is a crash. And identify protective innovations by using virtual testing and in particular human body models. And here we have developed, we aim to develop human body models of both an average female and an average male. And then share and foster knowledge by providing everything open source. And we were 15 partners in Europe. Let's see if I can get a better cursor here. I think I go with the laser pointer. Here, I think you see it a bit better. 4 partners from Sweden, and then around Europe with the OEMs, Volvo Cars and Siemens. Also provider of the software, LS Dyna, and provider of seats, both adult seats and child seats for occupants, vehicle occupants. We had benefited from a broad international group that we met with at several occasions during the project. And of course, when it comes to road safety, we have both regulation, but we also have of vehicles, we have consumer information. So we had in our advisory group Euro NCAP from Europe and the Insurance Institute for Highway Safety in the US. And you can see then the range of organizations that were connected to the project. And we have a vision that by 2030, in-Euro protection performances of new cars will be assessed for both women and men. And you might be aware of that is not the case today, since we have the average male as a norm. He is also the one that is required to be used in the UNECE testing, and therefore also, of course, the model that is used by the industry. So there have been no demand for a model of representing the female population, but of course the knowledge is out there that there is a need for it. So with inclusive crash testing, then of course the crash testing would be broader. Then we also identify the innovation protection performances that work the best for the whole population, and by that also provide a more robust safety performances. So this is how we described in the description of work what we aim to do. Here we have the human body models, and in gray here you see what did exist when we wrote the proposal. And you see that we didn't have any open source models. You also see that we didn't have, we had male models, but no average female models. You see that we didn't have any standing occupants at all, only seated as occupant, and that went for both males and females. And we also looked at standing occupant in public transport, and not only as bicyclists, but pedestrian, but also as bicyclists. And then there was a need for features when you are doing these simulations. And you can see here both structures of vehicles and different seats. And on this side, then you see what we have done in the project. So we have created the Viva Plus models of an average female, average male, as pedestrians, and all a lot of features that you need for doing the simulations, and then also as a standing occupant. Just to show you, I often get a question, what is the difference between the males and the females? And of course it depends on what you aim at assessing and what aspects. But here you see the difference in proportion, like in height in particular, but also in width. And here you see two of them side by side. What we also did for the low severity or impact test was scenario was to have also physical models that corresponded to our virtual models, but also to be used for the evaluation of seats. So we call them seat evaluation tools of an average female and an average male. And here you see, when we're now digging into the seat, then you see the differences in contours, which are of course of importance when we interact with the seat in a re-impact. And you can see typically here with women having broader hips and more narrow shoulder than the male. And here should be some simulations. Let's see if I can get this to work. I have to remove the pointer? Oh, I have to change to... Yeah, okay. Here we are. It started right away. Okay, then I don't use the laser because I have some illustrations here. So both you see a simulation here with the average female in a Toyota seat that we made a finite element model out of, and then also the seat evaluation tool of an average female in another seat. So here you see the average male and the average female in the same seat. So this is then gives you an illustration of the seated height, of course, and then also where you would interact with this with the head restraint in a crash. Of course, we didn't only look at seated occupants and re-impact. So we have a whole virtual assessment chain for vulnerable road users, looking at the effect of active safety and then also, of course, passive safety. And here should be simulations of a pedestrian hit by a vehicle, and then you can see the differences in particular where the male and the female ends up on the front of the car, with the male going up to the windscreen, but the female then will hit on the bonnet. And then going further, looking at public transport, here we had the tram provider Siemens, and looking at different contours and designs, how we could minimize the risk of the pedestrian being injured in a crash. So the results in brief. We had 39 journal and conference publications, 21 presentations, and 3 workshops being completed. We developed the OpenVT platform, which is available for everybody, where all the features are found. We have the Viva Plus models, the average male and the average female, that you saw some details about, and the seat evaluation tools of both the average male and the average female. We also looked at new seated positions of occupant and children. We had the virtual testing chain, as I described, and we looked at the public transport users and keeping balance when you're standing, and then cost-benefit analysis tool that also is found openly available. We had a lot of cross-project collaboration with both the Oscar and the Pioneer project. We had joint workshops, and we had globally discussion with both EuroNCAP and others that developed Insurance Institute for Highway Safety and others that developed also virtual tools. And then on the platform, we already have tools here you see from EuroNCAP, or material from Oscar. So the platform works as not only for our material, but also for others. Then on a few slides on impact. Several of us have been very involved in the work that has been done in the UNECE in an ad hoc group there. And for those of you that are familiar with that, there is now a suggestion from the GRSP to form a working group, and the formal decision will be taken early March. So this has been a global activity that has been very important and fruitful. Also in the roadmap for EuroNCAP, virtual testing, assessing safety for both males and females are on the roadmap for 2030. And we have formed an open VT organization where everything should be available after the end of the project and continue to develop. Then there also have been a lot of media attention throughout the project, since we have a very active dissemination partner and provided a lot of material. But just the last half year, the first average female model crash test dummy has caught more than 450 different media things around the world in more than 15 languages, and the highest exposure has been in the US and in Germany. So we have done our best to reach out. So thank you for your attention.
Thank you very much, Astrid. We'll take all the questions, if you agree, after the 3 presentations. I think with your project, Astrid, we have seen very much was that we still need passive safety research activities, and it should not be forgotten. So we invest a lot in automation. I think passive safety links with active safety, of course, is a key instrument. And I retain also very good result on a female crash test dummy that will be used now, which is important to have also the gender balance when we do safety. It's not only for an average male dummy. So I think it's important for the future. And you have very good also result on links with regulation, which is also important. Thank you.
Thank you. And I could comment on particular that because it was very encouraging in the ad hoc group that we have worked in the UNEC, where NHTSA presented their roadmap, and they have. We have, of course, had the dialogue. They have been part of our group, and so they are fully committed now, and also are very active in the UNECE work.
So maybe later on in the discussion we could further discuss this international cooperation aspect.